All right, this is the first lesson in our unit on integral. So now that we finished up derivatives, we were going to talk about kind of its inverse or integrals. So once you learn something in mathematics like addition, you're going to learn subtraction right after it. Multiplication has a division and derivatives have integrals. Integrals are all about area. And so we kind of got to back up and refresh how to find area again, just in case we forgot. So the area of a square, all sides are equal, would just be side times side or side squared. You could also do base times height, would get you the same thing. Circles, area is pi r squared. Make sure that the squared's on the r and not on the pi. Rectangles are the same as squares, and so area is just base times height. Triangles, area is 1/2 base times height. And trapezoids are, which we're going to use a lot of, 1/2 base plus base times height. And the bases, we're going to do some examples here, but the bases for a trapezoid are the two that are parallel, not necessarily the ones it's sitting on. Later on, we're going to do trapezoids that are turned on their side. And just so that you know that the bases are the ones that are parallel to each other, not the ones that it necessarily is sitting on. So find the area of each. First, we've got up a parallelogram, so just base times height. 8 times 12. And these don't really have units on them, so we'll just go with 96 units squared. Next up, we get a triangle. Make sure that you're doing base times height when you do a triangle. The base and the height have to meet at a 90-degree angle. So this is 15 and 19. Which would give me 142.5 units squared. Trapezoid, base 1 plus base 2. Again, those are the ones that are parallel to each other. And then times the height. So we've got 5, 14, and then 8, which gives me a total of 76. Two more. We got a square here, so if that side's 11, so is this one. So we got 11 squared, which is 121 units squared. Next up is a circle, so pi r squared. Since the number kind of runs over the line, we're going to take that to be the diameter. So we're just going to divide that in half to find the radius. So the radius is 12.4. And then squaring that and giving it a pi, we get about 483.05. That one actually has a label, so we'll make that centimeters squared. Where we're really going with this is being able to find the area under a curve. And we'll get a little more sophisticated at it in the lessons coming up here. But we'll start with these shapes. And they aren't exactly a shape overall, but we can break it up and just look at one part at a time. So this right here would actually be a trapezoid, and its two parallel bases would be running right here and right here. So we could do a trapezoid there. There could be a rectangle right here. We could kind of break it up. There could be another trapezoid right here. So all I'm doing is kind of chunking this up into shapes that I can deal with, since overall it's not a very good shape to find the area of. So the first one, this trapezoid right here, we would have 1/2 and then the two bases, so the base would be 2 and then 3. And then its height, which is right here, would be a 1. We're going to add that onto this rectangle, which is a 2 by 3. We're going to add that onto this trapezoid, and its base is 1, and then this base is 3, so we'll go 1/2, 1 plus 3, and then its height is 2 this time. Plus, we gotta sneak one more little rectangle in there, a little 2 by 1. So typing all of that in and figuring out your overall area, 6 and 4 and 2. So you end up with 14.5 for the area. This would also be pretty easy to just count up the boxes as well, since you're dealing with a scale of 1. You could count up and count how many boxes you have. Try and stick to the formulas, because as we move up in the different types of shapes, they're going to get a little trickier for you to just count. So this one we got a little square, which is going to be just a 1 by 1. And then we've got a trapezoid right here with a base of 1 and a base of 3. And then the height is 2. This would be a triangle right here. So 1/2 base, 1, height 3. And then we keep on adding here, except once you go below the x-axis, you're actually going to subtract these areas. So anything below the x-axis is considered negative area, so we're going to take that off. So we've got a triangle, which is a 1 by 1, so 1/2 of a 1 by 1. And we're going to end up subtracting that. So I'm going to take that off. We're also going to subtract off this next little square, so a 1 by 1. we're going to subtract off this rectangle, which is a 2 by 3. So putting all of that together, I end up with -1 units squared, negative, for my area. So there's a little bit more below than there was above. One last one, just finding area here. This guy is below, so we've got a negative in this rectangle. Actually, you could treat it like a whole trapezoid if you wanted. So that trapezoid would be 1/2. This is the base, which is 2, and this base, which is 3. Height is a 1. And then the area above would be another trapezoid. You could also break it up into like a triangle and a rectangle. That would work too. And the base here is 1 and 3. And the height is 2. So kind of putting all that together, we have a -3 below and then a 4 above. So this one ends up being 1 unit squared. So there's a little bit more above than there was below. So today you're just working on area, finding area of different shapes, remembering what that looks like, moving to area under a curve where you just kind of break it up into different shapes along the way and find their individual areas.